Next up, what we're going to do is we're going to use the same property, but we're going to try to apply it to a differential equation, because that's always the trickier thing to do. So this is 4.4.2, and it's a differential equation. X double prime plus 16x is equal to cosine 4t. X of 0 equals 0, and x prime of 0 equals 1. So this is a differential equation. The way we're going to start solving it with Laplace transforms is to take the Laplace transform of both sides and say that L of x double prime plus 16x is going to have to be equal to the Laplace transform of cosine 4t. And so let's start off by just taking those two Laplace transforms. We'll do the left-hand side first, I guess. L of x double prime plus 16x. I'm going to have s squared times capital X, and I'm going to put bars on my x's because I know they're not very easy to tell apart, minus s times x of 0 minus x prime of 0 plus 16 capital X. And when I go ahead and plug in my conditions, that's going to give me s squared capital X minus s times 0 minus 1 plus 16 capital X. And then since I know eventually I'm going to want to be solving for that capital X, that's just s squared plus 16 times capital X minus 1. And I'm not going to try and factor this yet. Maybe someday it'll help to factor into like s plus 4 times s minus 4, but I'm not sure about that at this stage. L of cosine 4t is pretty straightforward. You could just go back to your Laplace transform table. You know that it's going to be something that has 1 over s squared plus 4 squared in it. And then the thing that goes on top is going to be an s. Oops. Because the numbers are reserved for signs. And so what you have is putting these two things together. S squared plus 16 times capital X minus 1 is equal to s over s squared plus 16. Or capital X is equal to s over s squared plus 16 plus 1. Everything divided by s squared plus 16. So when I divide s squared plus 16 from s over s squared plus 16, that just gives me that squared right there. And from here, what I want to do is take the inverse Laplace transform to solve for little x of t. So I have little x of t would be L inverse of s over s squared plus 16 squared plus 1 over s squared plus 16. Oops. And we'll continue that on the next slide. So x of t is L inverse of s over s squared plus 16. Plus 1 over s squared plus 16. Oops. All right, so there's two parts to this, and what we're going to need to do is kind of note that thing that I told you to remember earlier. So remember, we saw that L of t sine kt was 2ks over s squared plus k squared. So in particular, that's going to mean that L of t sine 4t would be, well, actually, let me write that the opposite direction. So supposing I had s squared plus, oops, that should have had a squared there. Supposing I had s squared plus 16 squared, that means that I'm looking at k equal to 4. So 2 times 4 times s over s squared plus 16 squared is L inverse of t sine, is L of t sine 4t. So what I did here was I said, okay, that 2ks over s squared plus k squared squared followed from t sine kt, taking a derivative of L of sine kt. If I see s squared plus 16 squared in the denominator, that's a k equals 4. So I'm thinking about L of t sine 4t. Okay, so using linearity, what I have is I'm looking for L inverse of s over s squared plus 16 squared plus L inverse of 1 over s squared plus 16. And I'm also going to note we have from our regular Laplace table that L of sine 4t would have just been 4 over s squared plus 16. So I want this to look like that quantity right there. So I want to have 8s over s squared plus 16 squared. I know that that would be the Laplace transform of t sine 4t. So I just divide by an 8 out front so that I have that. Oops, forgot my L inverse. And then this one I want to look like 4 over s squared plus 16 because I know that that's the Laplace transform of sine 4t. So I better divide by a 4 to balance all that out. And then from here I can go ahead and take my Laplace transforms because I know what they are. The inverse Laplace transform of 8s over s squared plus 16 squared is t sine 4t. And L inverse of 4 over s squared plus 16 is just sine 4t. And that'd be the solution to my differential equation. I guess you could note real quick that you could have solved this using constant coefficients with undetermined coefficients for the non-homogeneous part, but we just did it with Laplace transforms. Oh no, I spun the screen. So that's a new method that's available to us. So I'm going to stop here and then we'll do another example next.